All right, in this lesson here, what we're going to do is take a look at inheritance. Very, very, very important concept to make sure you grasp because you're going to be using it often. We'll talk about what it is for starters and give some, I guess you can say, concept examples. And then we'll move into the syntax of it and implementation, et cetera, et cetera.
Yeah.
So, Joel, take it away.
All right, so the first thing is, what is inheritance? Well, basically, inheritance is the ability for us to derive a new object, but kind of grab some of the old properties or functions of another class so that we can build up from that.
That's right. Inheritance is essentially an addition, an extension to a previous class.
Right.
And we're able to basically get some free work out of it by having already defined information that we can reuse again in our new class.
Exactly. So why don't we switch over into Photoshop real quick. And Dan, why don't you show us the example that you want to show us?
The example.
Yeah.
We can start thinking about classes as we would life. Classes are essentially objects in the world.
It's a great box.
It's a great box. I'm going to call this an animal. Animal.
Okie-doke.
And essentially, an animal is going to have some functionality to it. It's also going to have attributes. We could think that an animal, for instance, has 50 organs. And this information can be passed down to other classes, which we could consider to be, say, a mammal.
So basically, a mammal is an animal.
Is an animal, but we could also say a fish.
So fish is also an animal.
Fish is also an animal, but they're different. They'll inherit the same information with, say 40 organs.
50.
50 organs.
Right.
Sorry. But we will be able to change the information if we want to. We could also say, just for one more example, a dog. A dog is also a mammal.
It's a mammal. But it's not a fish.
But it's not a fish.
Right.
That's important. It's a one-way street. It doesn't go both ways.
Right.
But we can change the information.
Oh, yeah.
We can change the information. So, like, say dog, we want to have 20 organs. I don't want to X the dog, but 20 organs. This will override this information of the 50 up top. But just remember that everything defined, like mammal, fish, will still have 50 organs.
Right.
As a default.
Yeah.
Because of the inheritance.
Yep.
Does that make sense?
Yes, it does.
Okay, good.
All right, so let's switch back over into .NET, VTM2. What am I thinking? And we, as you can remember, in the last lesson, we developed this point class.
Yeah.
Well, what if we wanted to just develop a little bit more and make it into a vector class? Well, as you may remember from your old school days, a point and a vector have a lot in common.
Yeah, because a vector is basically X, Y, and Z.
Yeah, and look, a point has X, Y, and Z. Wow.
And we're going to need to be able to set the X, the Y, and the Z.
Right.
And get the X, the Y, and the Z. So we could inherit the information from point.
Exactly.
And make a vector class.
Yep, imagine
awesome.
that. So what we need to do, but the addition, subtraction, that sort of operators are going to be different between a point and a vector.
Well, that's just gets down to the mathematics of it.
Right.
Because they're different creatures.
Right.
But they have the same basic information.
Yeah, they do.
And properties.
Right. So we're going to kind of just inherit from point to create our new vector class.
So how do we do that?
Let's come down all the way to the bottom here. And let's kind of just comment this off and say, ding, we can say point, class, end.
And the reason Joel's writing this below the already defined point class is because we need to know about the point class before we write the vector class.
Right.
If we put the vector class before the point class,
it wouldn't know where the point class is.
Oh, what's the point class?
Yeah, that's a bad thing. So all we need to do, like we did before, class, vector. Now, we want to inherit from point. So what we need to do is with the colon, we say public point. So that essentially says, I want to get all the functions, all the
public information
from point.
And be able to use that in my vector class.
That's right.
It'll become part of the vector class.
Exactly. So inside of here, what we want to do is let's declare the public section.
Okay.
And inside of here, we'll say, let's create a constructor. So float, just like we did before, capital X equals 0, float capital Y equals 0, and float capital Z equals 0.
So what we're doing right now is called we are rewriting the constructor if we didn't actually have this in there, it would be defaulting to the point functions constructor.
That's right.
But since we want new functionality, we're going to write our own.
Yeah.
Oh, okay.
So let's now define this vector class, well, this vector constructor that we've just created. So vector and our colon, and this is going to be the constructor. And again, we cannot redefine the default argument.
Values, yep.
So instead of here, we could just do this. Now, what do we want to set these to? We could, if we wanted to, come in here and just say set x, x, set y, y, set z, z, or something like that. But since we have access to our point constructor, if you will, we can come in here and simply use our colon here, and say point x, y, and z.
So the idea is we're able to call the inherited class's constructor from our own constructor.
Right.
And we do that with the colon operator.
Right, and we're passing it x, y, and z to save us time.
Okay, so that's going to initiate all the information that we need.
Yep. And if we wanted anything extra inside of our vector constructor class, we could add it right here, our vector constructor. So we can add anything we want right here.
But we don't actually need anything else.
In our case, we don't really need anything else.
Okay.
So let's just leave it at that. Now, back in our main function, it's empty at the moment. Let's declare a vector class. An
instance of the vector class.
Right.
Just like we did with the point class, except this time we're going to be making a vector.
Right. And we can send 1, 2, and 3 to this guy. Look at that. Everything's good, right?
Yeah.
What's wrong here?
Nothing that I can tell.
There isn't anything wrong. Haha, just seeing you're awake.
Something is wrong.
Yeah. Well, these are 2 warnings. Not allowed to return type. Let me see.
Oh, I see. Line 123.
I'm missing E.
Just like any other class, when we define it, we have to have the semicolon at the end. If not, we're going to get an error.
Yes, and we don't want that.
That's just one of those nitpicky mistakes that happens that you'll see every once in a while pop up in the code.
Yeah, that's right. So, I want to bring up another important thing. Since now we're dealing with inheritance, these private members are not brought into our class. They're part of the point class, so we can't access these directly.
Because it's still secure private data.
That's right.
That only the point class can access.
Exactly, so we still have to go through these functions to change this data.
But that's great by me, because I like the whole using the accessors
That's right. I mean, but if
data.
I came down here, and let's say inside of our constructor, I wanted to say x equals 5. All right? And if I try to compile that, cannot access private member declared in class point.
That could be a problem if you wanted to do it that way.
Right. What if, let's say what if you wanted to do that. What you would need to do is come up to here, back to our point class here, and change this from being in the private section to being in the protected section. This is still not accessible to everyone outside.
So as long as I'm related
you can access
to the point class, I can access it.
That's right. But it's not as global as our public section here.
Because that's anybody can
access it. With these, only family can access it.
Okay.
So if I brought, let's exit that. Let's just pretend, put float x, y, and z inside of protected. Nothing really is going to be broken here. If we compile it, it now works.
Well, that's because we kept the variable names the same.
Right.
And they're essentially serving the same purpose inside the class.
That's right.
So everything's fine.
Yep. But in our case, we still want to kind of keep that whole object-oriented kind of concept in mind here. So we want to keep data sort of protected, if you will.
Yeah,
private.
What you want is access to it in our future classes.
Right.
And this is the way to do it.
Yeah.
Okay.
So in our case, I do want to put it back into private.
Okay, so nix what I just said. We want to keep it private.
Yeah, that's what I meant.
Okay, that makes sense.
Yeah.
No, that's fine because it is object-oriented. It's good to keep as much data as you can protected, even from family.
Yep.
That's just good object-oriented programming.
It is true. So inside of here, let's delete the constructor that we had here, x equals 5, since that's not going to work anyway.
Yeah.
Now let's add a few operators to our vector class. So inside of here, let's add a addition operator.
Okay.
So let's say vector operator plus, and then we're going to pass it another vector. So a vector plus another vector. So that's an x, y, and z plus an x, y, and z.
So this is kind of like what we did before.
Yeah.
With the operators that we overloaded.
Yep.
Okay.
Very, very similar. So if we come into here, we can say vector, and then vector plus, with the colon, operator plus, and then inside of here, we're just going to pass it P. Then inside of here, all we need to do is add these two together and return that out. So, we first need to declare a temporary variable that we can return.
Yes, because the return command works by returning a value, which is returning a variable.
Yes.
Yes.
That sounded confusing, but yeah.
Yeah, sometimes I'm backwards in what I say, but...
You try.
I try.
That's all that counts. Hey, Buzz, you still alive over there?
Oh, yeah.
All right.
Just handling a few things in the background, unfortunately.
Yeah.
All is good.
That's good. So let's say out v, which is our new vector that we just created. We're going to set his x equal to our x plus the x that was passed to us inside of the vector p.
Okay.
So get x, dink, plus p dot get x. Simple enough.
That makes sense.
And then for the second one, set y. And since I'm lazy, I'm going to just copy this, paste, and paste.
Oh, no. Laziness.
It's good in the end, really.
Yeah, it is a little bit faster to cut and paste, I have to admit.
Yeah. Now, since we have that, we can just return it. Isn't that difficult?
Now, what I would like to see you do
Yeah.
is print that.
Print that out.
Well,
All right.
I want to see two vectors added together and print out the results.
Okay.
Because we haven't defined printing in the vector class.
Ah, I see what you're going for. So let's say vec2, and let's say 5, 4, and 2.
Okay.
All right. Now we can say, let's declare a new one. Vector vect3.
Okay.
All right. We can declare this as vec3 equals vect1 plus vect2.
Okay.
Now, what should it have inside?
Well, if I think about the addition, it should be 6, 6, and 5.
Yeah, exactly. So what we're going to do here is say cout vect3 and del.
But now, wait a second.
Yeah.
We never declared the equal operator, did we, for the vector class?
No, we did not.
Oh, but is there something with inheritance that lets us use
Hey, maybe.
that? Okay.
I'm going to play this once just so to prove that it is working. And lots of things going on here.
Yeah, that was from the other code.
Yeah, that was from the other code.
Which is actually good because we're seeing that we're calling the functions from the point class.
Yes, we are. And the reason for that is because if you remember, let me just pull this up for a second. In our vector constructor class, we're still calling the point constructor.
Mm-hmm.
So that's why, if you look over here, we still go and print we're in the constructor with arguments, blah, blah, blah.
Yep.
So you'll notice down here we have 6, 6, 5. Perfect.
So the addition worked, and the assignment worked.
And the assignment worked. Interesting. Now, let's go into here and put a breakpoint right here. Because I'm into debugging.
Yeah. It's nice. You can jump around the code and see what's going on.
Yeah, it's cool. So let's jump in and look at this. First we do our addition before we do our assignment. So we come into here, do our assignment, our addition, return out of it. Now, if we press F11 to step in again, dink, it just went over. Now, what it just did was it created its own equal operator in this case because they're both vectors.
Okay.
So if we go stop debugging for a second.
Which is what happened before we did a shallow. It was a shallow
copy. Yes, it did a shallow copy, and it worked. So if we want, we can go ahead and create our own equal operator if we needed to.
Okay.
But in our case, you know what? We don't need to. Right. So let's come down into here. And now let's create a simple minus operator. How's that sound?
That sounds good.
So let's come into here and say vector. Now this is just what you've seen before, but we're just kind of driving it home because if you don't understand inheritance, you're going to have problems when you start dealing with a lot of different things. Programming games, API stuff, everything.
Which would be in the next BTM.
Yeah.
Well, at least some game stuff would be in the next BTM.
Yeah, it's important to have it all in there. So vector of v, and we do the same exact thing except we use minus instead of plus. Therefore, I'm going to be lazy yet again. Copy, paste, and change this to minus, minus, and minus. Simple enough?
That seems simple.
What did we miss?
Did we declare it in the...
No, we didn't. We didn't put a prototype. That's a bad thing. So let's come in here, put this prototype in here with our semicolon. Now let's just compile this, make sure everything's good, and it is. And if we come into here and minus this, but let's minus vector 2 from vector 1. That'll give us a better value, at least in my opinion. So let's print this out, and you'll notice if we just move this out of the way, we have 5 minus 1, 4, 2, and -1. So everything's working just the way we want.
Seems to work. And what I'm just noticing now is that we never defined the output operator with cout.
No, we didn't.
But yet we're able to use it.
Yes, let's go into here and debug, because I did forget about mentioning that one. It's kind of important.
Well, it is, because it sort of will illustrate inheritance.
Yes, it will. So let's go into here, and let's just press F11 at this point. And look at this. This is what we created before, but it's using point P, so it's accepting a vector even though it's looking for a point.
Now, why is that?
Well, because a vector is a child of a point.
So a vector can be thought of as being a point,
Yeah,
as long as you only use the functions that a point has.
that's right.
So since a vector has points functions,
Right.
as long as we use points functions,
We're
good.
going to be fine.
We're good. Okay.
Yeah. So inside of here, it prints it out. Everything's good. Woohoo! Life is great. Now, I'll do one final example, and that's how we can go about using vector multiplication.
Okay.
But in this case, we're going to do something interesting. If we did regular scalar multiplication, what would we do? The left side would be a vector. The right side would be
Now,
a double or something.
let's talk about scalar multiplication
Okay.
and vectors a little bit.
Okay.
What exactly happens?
The magnitude changes.
The magnitude changes, which means
You tell me.
basically we multiply each
Each
x,
component
y,
by
and z by some number.
some constant. No, not some constant, some variable.
Some variable.
Right. So, we
It sounds complicated, but it's actually
very, very
very
simple. So, how can we do this? Come into here, and in this case, we're going to do a multiplier. And we'll just pass it a float x. Or no, let's not use x. Let's use
Scale.
scale. Now, inside of here, let's come over to here and say vector, because it's returning a vector, and operator, multiply. And it's going to be float scale, right?
Yes.
Now, same as we did before, let's just copy this. It's going to be a little bit different, but still very similar. And this is going to be changed to get x multiplied by scale. And multiplied by scale.
You're not doing the cut and paste job.
No, I'm not.
No.
It's okay. So that's how simple it is. So if we come down into here, you'll see where I'm going in just a few seconds. Times 4. No, I'm sorry. Vect1 times 4. So that's going to make Vect1 4, 8, and 12.
Okay.
So if we print this out, dink, 4, 8, and 12. All is good, right?
All seems very good.
What if we happen to do this, though? 4 times Vect1.
I don't know.
Dink, we have an error. Binary multiplier. No global operator found, which takes type vector, or there's no acceptable conversion. The reason for this is it's accepting as the left operand a vector, and the right operand is going to be a float.
That's because when you're dealing with overloading operators inside of a class, you sort of automatically get who you are.
That's right.
So you don't
So
need
you
it.
get the this.
Yeah, you get the this.
What if we wanted to change it? Well, in this case, notice this is part of the vector class. In this case, we're going to have to make it. It can't be part of the vector class anymore.
So in other words, we can't say 5 times a vector.
Right.
We can only say a vector times 5 because of the way functions work.
Yep.
Okay.
So we need to change this to say, create a new function that overloads with the left side being the number and the right side being the vector.
So is this going to look a lot like what we did above?
Yep, with the output operators, output and input. If we just scroll back up here, you'll notice it'll look very similar to this. This is going to be a vector. This is going to be a float. And this is going to be our vector.
Okay, so this way we can actually define the operator, the
Yep.
argument list. Okay.
So let's come back down to here, and let's do this guy. So operator, multiply, constant, float, because we're not going to be changing it. And we'll just pass it by reference. And this is going to be vector. If you want to say anything while I'm typing, I'm perfectly cool with that.
Okay.
Elevator music, I don't know, anything.
I had a really lovely dinner tonight. It consisted of sort of Chinese food, some egg rolls. It was really good.
Alrighty.
I just thought, you said talk, so I'm just talking.
That was a good effort, really.
Yeah, thanks. What I'm impressed with right now, getting back to the code,
Mhm.
is how little we've changed
Right.
to get so much functionality.
That's right.
And
We don't
because
need
we
to
haven't
redo-
changed really anything.
Yeah, we haven't.
We've just expanded, adding multiplication, subtraction,
and addition. Yep.
And everything else came along for the ride from the point class.
Yep, set X, get X, all that stuff.
Yeah, I mean, that to me is
cool.
Powerful. And
yeah,
cool.
Very, very cool. So now we can do exactly the same as we did with this multiplier. Dink. Only difference is, well, let's get rid of that. This is going to be v.getX, v.getY, and v.getZ. Dink, dink. All is good. Now, if I compile this guy now, no more errors. And you'll notice that we still have this 4 multiplied by vect1. And if we run it, we still get the same value, just as if we did vect1 times multiplied by 4.
So if you were to debug that, it would step into the function you just made.
Yep. So let's go ahead and do that just to make Dan happy. So let's press F11 to step in. And you notice this is the function that we just created. So dink, everything works awesome. How's that?
That's pretty cool.
So actually with that really does... That's pretty much all there is to inheritance.
Excellent.
So
with that, it's going to... Go ahead, Dan.
I was going to say, and it's just amazing how fast it took to make a vector class.
Yeah, no, it is.
Because it took us a while to make the point class.
And if you don't entirely see the use of inheritance, although this is an excellent example of inheritance...
You're going to see it.
You're going to see it really soon. So
a lot of it.
Oh, yeah.
So with that, that's going to bring both this lesson and this VTM to a close. So thanks a lot, everyone. See ya.